we are given two equations, both of them involve modulus, and we are asked to calculate the length of the segment where the first equation is greater than the second one. If you're looking at both the modulus, the inflection point for the first one is minus 5 by 2. That is, whenever x is less than minus 5 by 2, the term inside the modulus will be negative, and when x is greater than minus 5 by 2, the term or the expression inside the modulus will be positive. Similarly, for the second one, the inflection point is minus 7 by 6. To actually understand this question better, let us first draw both the graphs. Drawing the graph will involve first taking note of the inflection points. This is the y-axis and the x-axis respectively. The inflection point for the first one is minus 5 by 2, so it will be a V-shaped line which will touch the x-axis at minus 5 by 2, and then it will continue to rise up. It will be a symmetrical graph. Another thing to notice is at what point does it intersect the y-axis. This, as we have discussed, is minus 5 by 2, 0, and when x is 0, the value of y1 will be equal to 5. So this point will be 0, 5. This will be a V-shaped graph. Similarly, if you are looking at the second one, this is equal to modulus of 6x plus 7. The inflection point is minus 7 by 6. So it will also be a V-shaped graph, but it will have a steeper slope. The reason for that is because the slope is equal to 6 for the second one, and it is equal to 2 for the first one. So essentially the second graph will be like much more steeper. It will go higher much faster. This point for the second graph is minus 7 by 6, 0. And at what point does it intersect the y-axis? That is, what is the value of y2 when x is equal to 0? When x is equal to 0, that will be equal to 7. So this is 0, 7. What we are required to calculate is the length of this line segment. This is the part where the first graph is actually higher than the second graph. How can we calculate the coordinates of this point? We should have a rough idea of where the points lie. The first point, if you are calling this A, and if this second point is equal to B, the x coordinate of the first point is greater than minus 5 by 2. And it is less than minus 7 by 6. You can understand that from the graph. And for the second one, if you are calling that D, the x coordinate of the second point is greater than minus 7 by 6. This is what we should look at when we are drawing the graph, so that we have a rough idea of where the points lie. That is important because then you can easily calculate the values of the coordinates, because you can figure out what is the value of y1 and y2. Because is it greater than the inflection points or not is something that we should take a call before we actually start proceeding further. So if you are trying to calculate the value of ax, we know that this is greater than minus 5 by 2. So 2x plus 5 will be positive. And we also know that ax is less than minus 7 by 6. So 6x plus 7 is less than 0. Therefore, the coordinates when both the graphs actually intersect, the equation should be that modulus of 2x plus 5 is equal to modulus of 6x plus 7. This is for A. And in that case, we know that 2x plus 5 is greater than 0. So this is 2x plus 5 is equal to, and 6x plus 7 is less than 0, minus 6x minus 7. Or the value of 8x is equal to minus 12, or the value of x is equal to minus 1.5. Then what is the value of y? Y will be equal to modulus of 2x plus 5. 2x is minus 3 plus 5 is equal to 2. So the value of A, the first coordinate which is to the left, is minus 1.5, 2. If you are trying to find out the coordinates for B, what do we know about B? We know that the x coordinate is greater than minus 7 by 6. Therefore, it is also greater than minus 5 by 2. It is to the right of both of these points. So the value of 2x plus 5 is positive. Similarly, the value of 6x plus 7 also is positive in the case of B. So if you are trying to equate modulus of 2x plus 5 to be equal to modulus of 6x plus 7, it will simply be equal to 2x plus 5 is equal to 6x plus 7. Or the value of 4x is equal to minus 2, or the value of x is equal to minus 0.5. Then what is the value of y, which is equal to modulus of 2x plus 5? That will be equal to 4. So the coordinates of B is minus 0.5, comma 4. What is the length of the line segment AB? That will be equal to square root of the sum of the squares of the difference in their coordinates. That is, it will be square root of 4 minus 2 whole square, which is 2 square, plus minus 0.5 minus of minus 1.5, or essentially that is equal to 1 square. This is equal to square root of 5. By drawing the graph, we have a rough idea of where the points of intersection actually lie. The only thing that we need to figure out is, are these points of intersection to the left or right of the respective inflection points? We know that A lies between both the inflection points and B lies to the right of the second inflection point. Once we know that, we can figure out the signs of 2x plus 5 and 6x plus 7 easily. Without even drawing the graph, you can solve this question, but then you will have to consider multiple cases. And some of the cases you will have to say that they will be contradicted, so you will not pursue them. But if you draw the graph, it will be easy for you to pinpoint what are the cases that you need to consider. And getting the answer is slightly faster. So the correct answer in this case is square root of 5.